Welcome to this lesson. Now that we have a better understanding of how Lambda works, we need to be aware of its limitations to avoid unwanted surprises. We're going to cover three different types of limits: throttle limits, resource limits, and functional limits. Let's start with throttle limits. Throttle limits are actually there primarily to avoid accidents. Say for example that you start playing around with Lambda and you underestimate how often your function will get called, or you could even create a recursive call which would cause Lambda to continually run. Obviously, this would be bad for both Amazon and for your wallet, so they've added throttle limits. What are those limits, and what happens when you reach them? Well, as of right now, the limit is 100 concurrent function executions. This is not per function, this is the total of all concurrent function executions per region. Now keep in mind, though, that a single function execution isn't immediate. It could take anywhere from 1 second to multiple seconds, so one concurrent execution needs to account for the execution time. The formula to calculate the number of concurrent executions is the average function execution time times the number of requests or events processed by AWS Lambda. So for example, if we received 50 events per second from Amazon Simple Notification Service, for example, and the average execution time takes 2 seconds, that equals to 100 concurrent executions because we multiply 50 by 2. And this is the throttle limit, and Amazon may throttle you beyond that point. Now, if we also have S3 notifications coming in, we're going to go over our limit. So depending on your scale, that may not be enough concurrent executions. If that is the case, you can contact Amazon and ask them to raise your limit. So what happens when you exceed your limit? Well, if you get throttled, CloudWatch metrics will log this and can notify you. If the execution is asynchronous, then Lambda will continue to try for anywhere between 15 to 30 minutes unless it succeeds before that. However, if the request is synchronous, then it returns an error code of 429. If you remember from previous lessons, this is necessary because the source that invoked our function is expecting a result, so it can't just receive it at a later time. Now, there are 3 exceptions. Amazon S3 will continue to try for up to 24 hours, and Lambda will keep trying with DynamoDB and Kinesis streams until the data expires, which is after 24 hours. Now, let's move on and talk about resource limits. AWS Lambda allows you to create threads and processes because you can use normal language and operating system features. You can launch processes using any language supported by Amazon Linux, which includes Bash, Go, and Ruby. Now keep in mind that resources are shared among all threads and processes in a function, and you are limited to a total of 1,024 processes and threads combined. You are also limited to 1,024 file descriptors, so keep that in mind if you are opening connections, opening files, and that sort of thing. On top of that, you are also given 512 megabytes of non-persistent disk space in the temp directory. Remember, AWS Lambda is stateless, so if you need to keep data, make sure you save it in a persistent service like DynamoDB or S3. Other resource limits include a maximum of 300 seconds execution time, which is 5 minutes. If you need to process something and it takes longer than 5 minutes, you're going to have to find another way. Now, when using the invoke API to invoke functions, your request body payload size cannot be over 6 megabytes, and the same goes for the response body payload size. Now, when it comes to deploying your packaged code, which you developed locally and then zipped up, and you are now uploading to AWS Lambda, we have a restriction of 50 megabytes per deployment package. Then when it comes to the total size of our code and dependencies, they need to be under 250 megabytes. Then, the total size of all combined deployment packages in one region can't be over 1.5 gigabyte. Finally, we are limited to 50 scheduled events, which we went over in a previous lesson. Now, there is one more kind of limitation that I'd like to cover before moving on: functional limits. By functional limits, I mean limits to how we can leverage Lambda for our needs. The first functional limit is what I'll call cold start time. Cold start time is how long it takes for your Lambda function to boot up and execute when it's not already primed and ready to go. This is definitely something that caught me by surprise the first time I used Lambda. It was strange because the first time I opened up my mobile application, it felt like it took about a second to load the information. But if I closed the app and restarted it shortly after, the information displayed almost instantaneously. I was really puzzled by this, but it turns out that the first time AWS Lambda executes your function, the container must be started. We'll call this stage warming up as a figure of speech. Once it's warm, the function can execute a lot faster. But if you don't keep executing that function within a certain time period, the container cools down and you start seeing that cold start latency time again. This window of time depends on different factors, so test it yourself if this is very important to you. So how much extra time to the execution does the cold start add? Again, it really depends on a lot of factors, so I can't give you a number. In my experience, Java does usually take a bit more time than Python or Node.js, but it depends on the dependencies you have and other Amazon-controlled factors. It also depends on how much memory you have available to your Lambda function. Remember how we can decide how much memory to allocate? Well, the more memory we add, the more CPU performance we also get. This is nice to know because even if our function only requires 128 megabytes of memory to execute, we could allocate 1024, and that will increase the CPU available by a factor of 8, because we take 1024 and divide it by 128. If you do this, you could see faster cold start times, and your function could execute faster. I say could because you need to test this with your function to be sure. This depends on too many factors for me to say that it will always work. Alright, so we've covered different types of limits, and now we're ready to move on to the next lesson. Go ahead and complete this lesson, and I'll see you in the next one.